So there's got basically two main types of solving. Solving where we're going for all the solutions, and solving where we're going for only some of the solutions. So we're going to first look at all solutions. So solving for all solutions. Now a lot of these are going to be able to be do or expected to do without a calculator. So let's start with this one. 2 tangent x minus root 3 equals tangent of x. And I expect you to be able to do this without your calculator. Any suggestions? Okay, got tangent from both sides. So minus tangent x minus tangent of x. What's 2 tangent of x minus tangent of x? Wait, tangent x minus root 3 equals what? 0. Okay, then what? Add root 3. So tangent of x equals square root 3. So where does tangent equal root 3? What angle?
Oh.
Or angles, I should say. Notice it would be root 3 over 2 divided by 1/2. Which angle has root 3 over 2 comma 1/2? So pi 6, what's y? Y is 1/2. So this isn't pi 6, which angle would it be?
Oh, pi 30.
So we're looking at the angle in here where the point was root 3 over 2 comma 1/2.
Oh.
Right? Do you understand that? Well, how would we simplify this right here? Now 2 cancel, leaving root 3 over 1. So our goal was saying which angle will give us this fraction. What would be another fraction that would get the same answer? Negative and negative. Right? Because if they're both negative, then we also get the positive root 3. Now, what would happen if I did 1/2 over root 3 over 2? Would I get the same answer? Is that the same? No. Okay. So, everybody convinced that this is going to be at pi thirds? Now, is that the only solution? Okay, well, where are they both negative at? Exact opposite side, which would be what? How do you get to the exact opposite side of the circle? Add pi. What's pi thirds plus pi? 4 pi over 3. That is this one over here. Okay? Are those the only two solutions? So let's keep going around the circle. So we went here, here. What do we want to continue around? Where am I at? 7 pi over 3. And we keep going. What's the next one? Okay, and if we want to list all of them, how long would it take you? It's infinity. So we want to be able to simplify it a little bit. What equation could I write that would describe all of these? What's pi? Just pi? Pi n. And what's your about n? Yeah. Tangent is y over x.
Oh, when you put those watching down for 5 and 6, would you have that was 5 or 6?
No, This one is pi third.
So the one up there.
Yeah, the one I put up there was pi third.
Okay.
Which would give us a different answer. So that's, okay? But what, pi 6, what is the coordinate for pi 6? Oh, it is, what is x? Root 3 over 2, comma, y is 1/2, right? Okay? Tangent is y over x, which would be 1/2 over root 3 over 2. And that does not simplify to be just root 3. Yeah, that would be root 3 over 3. Good. So, our answer for this one, this tells us all solutions that would work. So we found pi third, and we know tangent repeats every pi, so we can go doing it. What if we were doing sine or cosine, what would we have to do? How often do sine and cosine repeat? No, not pi half. What's the period of sine and cosine? 2 pi.
Oh, yeah.
So they would repeat every 2 pi. So let's see. How about another one of these? Make it a bit more complicated. Tangent squared theta minus tangent theta equals 0. Okay, factoring, good. So just like if this was x squared minus x equals 0, you could solve that by just factoring out an x. So now we'd have tangent times tangent, or tangent theta times tangent theta minus 1 equals 0. So now, how do we work with this? No. So look at this one. If I factor it out, this we'd have x minus 1 equals 0. What would my solutions be? Yeah, I'd say x equals 0 or x equals 1, right? So I'm going to do the same sort of thing. Tangent theta equals 0 or tangent theta equals 1. Is that clear? And you see how it compares to what we did right there. Okay, now, where is tangent equal to 0? 0, pi, 2 pi, and so on. So we can say theta equals 0, or just say theta equals pi n. A question? Or? Okay. Because notice if I plug in 0, pi, 2 pi, 3 pi, 4 pi, all of those would work. Do you follow that? Anybody need more explanation on that one? Okay. So, basically if we were listing it, remember tangent is y over x, right? So, where is it 0 over 1 or 0 over negative 1? Where are the 2 points on the circle? Okay, 0 would be y is 0, x is 1, or pi. So you have 0, pi, and if you kept going, it would be 2 pi, 3 pi, 4 pi, 5 pi, all the way around, and we keep going. So any multiple of pi works. That's where we're getting n pi. Okay, so then this one. Where does sinus or tangent theta equal 1?
Oh, no. Yeah.
Where? Pi 4. So you'd have up here where they're both, it's root 2 over 2 and root 2 over 2. That's 1, so that's one of them. And the opposite would be over there. How far are they apart? Pi. So I can say theta equals pi over 4 plus pi n. N is an integer. N is included in, so it's just saying n is an integer, is another way of writing it. You could just say n is an integer if you wanted.
When we answer your questions, do you put both of those or just pi n? When we put 0 and then...
Well, what do you mean, like, do you want to put all of them?
If you want this part right before the tangent or 0.
You wouldn't have to write that because I would expect you to show this work that you got here, but from here it's very obvious where this is coming from. So you wouldn't need to show that part, although it would probably helpful to make sure you're keeping track of what you're doing. Yeah.
So when you put the answers, you put and or?
This should be an or. So just like when you're doing quadratics, you put or. Okay, does that make sense how we did that? Okay, we've got, now how about some sine and cosine ones? Let's see, start with a more complex one. Cosine cubed x plus cosine squared x minus cosine x equals 1. Okay, unfortunately it's not going to work with this one. You can do that, but what's the problem? That one. Yeah, so we're going to have cosine cubed x plus cosine squared x minus cosine x minus 1 equals 0. What method do you work for solving this? Factoring, yes. What's our method for factoring when we have 4 parts? Factor by group mean. Do you remember that from algebra 2 and algebra 1? If you had x cubed plus x squared minus x minus 1. No, not remembering that? What do you mean by, here, group it, and I'm going to put a plus between them. Is that look familiar? No? Okay, well, so how would we factor, look at the first part, what's common? You're going to have x squared, and what's left over? Okay? Plus, what's common here? Negative 1, so instead I'm going to change it to minus x plus 1, or negative 1 x plus 1 equals 0. Does that look like stuff you've done? Okay, now, factor out what's common in the 2 parts. Oh, what's common in the 2 parts? X plus 1, which leaves us x squared minus 1 equals 0. And let's finish factoring this. X plus 1, x plus 1, x minus 1. So now, if we go back to cosine, now these two are the same, so they'll yield the same solution, right? So I'm going to leave it as cosine x plus 1 squared and cosine x minus 1 equals 0. These two are the same. So now, what does cosine x equal to? Equals 1, or cosine x equals negative 1. Oh, it is plus or minus 1. Plus 1 and minus 1. So, notice this one is actually generating this solution, this one's generating that solution. They're actually going this way, but it doesn't matter which one. You got both. Now, where does cosine of x equal 1? Zero. Where else? What's cosine equal to at 5? Negative 1, so we can put it over here. X equals pi. Yeah. So how would I write the equation for this side? 2 pi n, and how would I write for this one? 5 plus 2 pi. Yeah, is there any way you can combine them? Yeah, but good. We're at 0, pi, 2 pi, 3 pi, 4 pi. So what would be a simpler version than putting both of these? Yeah, x equals pi n. And n is an integer. So that's it's oftentimes helpful to be able to combine these, so make it a little bit simpler. And basically, to be able to do that, you just look at what is the pattern. Like we said, 0, pi, 2 pi, 3 pi. If there wasn't a simple pattern like that, you could leave it with two separate things. Now let's do some secant. So let's see, 1 over secant theta minus 1 minus 1 over secant theta plus 1 equals 0. No, not equals 0, equals 2. How do we do it? Okay, common denominator is probably a good bet, which means what am I going to need to do? Secant theta plus 1, secant theta plus 1, and over here, secant theta minus 1, secant theta minus 1. So on top, I'm going to have secant theta plus 1 minus secant theta minus 1 all over, okay, what? So the bottom is going to become secant theta minus 1, secant squared theta minus 1, which is, is it tangent squared? Okay. Tangent squared theta. So how can I simplify this? Okay, so these are going to cancel. Well, the secant and the negative secant. And then what's 1 minus the negative 1? So 2 over tangent squared theta equals 2.
How does those two jobs cancel each other and multiplying and adding?
Show us by taking away the parentheses.
Okay, so I talked about here. Okay, so we have secant theta plus 1 minus 1 times secant of theta minus 1, right? And so if I take this negative 1 distributed, this is going to become minus secant theta, negative 1 times negative 1 plus 1. So I'd have secant theta plus 1 minus secant theta plus 1. So secant theta minus secant theta, 0, 1 plus 1, 2. Now what? Okay. So multiply tangent squared, so I have 2 equals 2 tangent squared theta. So 1 equals tangent squared theta. Then what? Square root, plus or minus, so plus or minus 1 equals tangent theta. Then, how many answers are there going to be from 0 to 2 pi? 4, right? Because where is tangent equal to 1? 5 4. Where is it equal to negative 1? 3 pi 4, and then 5 pi over 4, 7 pi over 4, and then can you count me? How far are these apart? By half. Good. So how would I write my general equation? Yeah, pi over 4 plus pi over 2n, with n being an integer. Any questions about how we did that?
So you take the lowest possible answer and then you add the distance times.
Well, if it keeps having the same consistent distance, yes, that will work. Like in this case, that works. However, if for example we got something, there are cases where you might get something like pi third and pi fourth, and so the next one would be 4 pi third and 3 pi fourth. So you won't be able to combine the pi third and pi fourth. You have to have 2 separate things. Does that make sense? Okay. So the second part of the question is, what if we just want solutions in 0 to 2 pi? Because some of the problems are going to ask for all solutions, which are looking for an answer like this. if it asks just 0 to 2 pi, what are my answers here?
All the answers are
Yeah, right there would be my answer.
so they be negative.
But that's not in 0 to 2 pi.
Yeah, but I mean, if it was for all.
Well, no, there is a positive equivalent. So, but yes, notice if I plugged in, for example, -1 for n, -1 is an integer. So pi fourth plus negative pi half would give us a negative pi fourth.
What is n?
N is an integer. It's basically some multiple. So I can multiply it, choose any number I want for n that's an integer. So any, like -15 if I want it. I can plug -15 in here. -15 times pi half plus pi fourth will be a solution. It will either equal 1 or negative. Yeah.
For the answer for that, could you just, we just say the answer and on the bottom, put n is less than or equal to 3 and then when it equals to negative.
You could, however, it's
0 to 1.
yeah. However, it gets messier. And in some cases,
Would that be wrong though?
not strictly. However, when it's asking for 0 to 2 pi, it's actually asking for individual answers. Most likely it'd get marked wrong. Technically, yes. Okay, start doing this one, 0 to 2 pi. What would be my answer? Okay, so it would be pi, the other. 0, 2 pi. Does that make sense? Okay. How about this one? Answers in the 0 to 2 pi range. Okay, 0, pi 4, 5, 3 pi 4. Is 3 pi 4 one of them? No, okay. 5 pi 4. And 2 pi. Basically, I was going by this one. This one you give us 0 pi and 2 pi. This one gives us pi 4, and then add pi, get 5 pi 4. That's it, there you go. That was all of it. So we know we can put 0 to 2 pi. It is fairly simple. We just look for all the answers that are on the unit circle. And I think I want to do one more here. So how would I do with this one? Okay, what? Okay, factor out sign. And what am I left with? Okay. So, first, what are my solutions for this one? So x equals 0. Let's just go in the 0 to 2 pi range for this one. Okay, 0. Any other solution for sine equals 0? I should say theta equals 0. Any other angle? Pi, 2 pi. Okay, that takes care of that one. And then what about this one? How would I know for this one? Any suggestions for that second part? Okay, so this one, we got this. When they both equal 1, is there any remaining circle they both equal 1 at? Oh, equal 1? Or they both equal the same thing. So where is sine supposed to equal the same thing? So pi 4 is 3 pi 4 the same. Okay, why not? One is negative 2. That's not pi. Pi 4. And pi over 4. So that one comes from here. Now, if I were writing a general rule, so if I was looking for all solutions in this case, could I combine these two? And what would be the pattern that describes both sets? Okay, at 3 by 4, what is cosine? You'd have negative root 2 over 2. And what is sine? Root 2 over 2. If I took root 2 over 2 minus negative root 2 over 2, do I get 0? No. Remember, we want this to be true, where sine minus cosine equals 0. If they're both positive, if I subtract them, then they're equal to 0, right? Or both negative. So what equation can you come up with, or can you come up with equations combine all 5 of these? What was the one for just this part? 5n. And this one? And I don't think there's any nice equation. There might be an equation you come up with, but it would be very, very complex and beyond the scope of the class. In other words, it would be fairly challenging. I mean, I probably have to be plugging into a computer to see if there's any pattern matching that could make it happen. So if you came up with this, definitely don't try to come up with an equation. You've got two completely separate patterns. So homework 5.3 is going to be a largely algebra thing and partially, you remember your unit circle thing.